If you're having a cheeky one on a Monday, as per usual, and smashing your beverages back, how can we model the amount of alcohol in your bloodstream at a given time? Well, if we let A equal alcohol in bloodstream as a function of time, and say you're drinking at a constant rate B, and if the amount of alcohol being cleared by your liver is proportional to the amount of alcohol in your bloodstream, then putting these ideas together, we can get the rate of change of alcohol in your bloodstream over time. And what type of equation is this? It's a differential equation. So what is a differential equation? A differential equation is just any equation that has one or more derivatives in it. Like this is the simplest differential equation I can think of. It has a derivative in it, so it's a differential equation. The order of the differential equation is the highest order of derivative that appears. For example, this is a first-order differential equation, and this is a second-order differential equation. Linear differential equation. A differential equation is called linear if its dependent variable and its derivatives are only to the first power and not inside any functions. So basically, it's not linear if you see anything like this. Separable differential equations. A differential equation is separable if you can rewrite it, so the y's are on one side and x's are on the other. That's all the jargon you need to know for differential equations. Solving them, you're just trying to find the dependent variable. Solving separable first-order differential equations are quite simple. Firstly, just put all the y's on one side and all the x's on the other. This is just basic algebra. Next, you can integrate both sides. Now here is important. Instead of doing to constants of integration, just do one big C. Now it's just algebra to rearrange for y. Here's a fun fact. So raising the whole equation to e, you get Okay, first of all, if the equation is separable, then do the separating method. It's way easier. But if it's not, you gotta do this method called integrating factor. Alright, here's an example of a first-order differential equation. When solving these things, it needs to be in this form. So basically, the left side has the derivative of y naught multiplied by anything, and y. The left side just has some function of x. So for this equation, we just divide by x.
Wow!
Now stay with me here. This should make sense in about a minute. Now that it's in standard form, we create an integrating factor, which is just e to the power of the integral of the function in front of y. So for this equation, don't worry about the plus c. Okay, now, if we multiply the whole equation by the integrating factor, it looks even more complicated. But no, look here. It's the frickin' product rule.
What?
So this whole left side can be simplified to this, which is just the derivative of the integrating factor times y. Now we can integrate both sides easily. And then once again make y subject. Okay, let's do this example using separating variables and then using integrating factor. Okay, firstly, let's separate the variables. Now integrate. And this here can be rearranged to this. Integrating factor method. Okay, here it is again. This time create the integrating factor. Okay, once you have the integrating factor, you should be able to just jump to here. But I don't know how your school works, so to be safe, in a test or something, you could do full working. But anyway, once we're here, we just gotta do integration by substitution. But because we're Math Dude 67 subscribers, it's barbecue chicken from here.